Consider this specific satellite image. A peak in western Tibet, 6,738 meters above sea level. From the north face, meltwater flows northwest, eventually becoming a river that travels over 3,000 kilometers to the Arabian Sea. From the east face, meltwater flows east, eventually becoming a river that makes one of the most dramatic geological turns in the world, through the deepest canyon on Earth, before traveling to the Bay of Bengal. From the west face, meltwater flows west into a valley system that drains south toward the Indian subcontinent. From the south face, meltwater flows south into a river that becomes a tributary of the most religiously significant waterway in human history. 4 rivers, 4 cardinal directions, 1 mountain. Within a radius of approximately 100 kilometers, all 4 originate. There is no other place on Earth where this happens. Not approximately, not where 4 rivers sort of flow from a region around a peak, where 4 distinct river systems, rivers that collectively sustain the agricultural foundations of the Indus Valley, the plains of Assam and Bangladesh, the Punjab, and the Gangetic Plain, all originate within 100 kilometers of a single 6,738 meter summit. The hydrology is confirmed. It is not disputed by any competent geographical authority. The Indus, the Brahmaputra, the Sutlej, and the Karnali all trace their headwaters to glaciers and snowfields within the drainage basin surrounding Mount Kailash in the Ngari prefecture of the western Tibetan Autonomous Region of China. This is the fact that sits at the center of everything else discussed in this script. Not the religious significance, not the pyramid shape, not the restriction on climbing. The hydrology, the fact that a single mountain in an unusually remote corner of the Tibetan plateau is the hydrological source of water that 4 ancient civilizations built themselves around, and that 1 billion or more people currently depend on for agricultural irrigation. Everything else, the sacred traditions, the geological mysteries, the unanswered questions, is context for that central, extraordinary, physically confirmed fact. Mount Kailash sits in the Ganges Range, also called the Trans-Himalayan Range, in the Ngari prefecture of western Tibet, at approximately 31 degrees north latitude and 81 degrees east longitude. It stands at 6,638 meters, not a particularly remarkable altitude by Himalayan standards, well below the elevation of Everest, K2, Kangchenjunga, or dozens of other summits in the range. What distinguishes it is not its height, but its position. It occupies what hydrologists call a continental divide, a point where water falling or melting on different sides of a topographic high flows in fundamentally different directions toward fundamentally different drainage basins. Kailash is not merely a continental divide in the ordinary sense of a ridge separating 2 river systems. It is a point from which 4 major river systems radiate in 4 different directions toward 4 different drainage basins and 4 different oceans. Hydrologists describe the Tibetan Plateau as the water tower of Asia. Within that water tower, Kailash is the mechanism at the center. The Indus River, called the Senga Kabab in Tibetan, the Lion River, begins its journey from glaciers and springs near the north face of Kailash, flowing generally northwest, through Ladakh before turning south, through the Karakoram, and then west and southwest through the full length of Pakistan before reaching the Arabian Sea. Its total length is approximately 3,180 kilometers. Along its banks, beginning roughly 5,000 years ago, one of the earliest urban civilizations in human history, the Indus Valley Civilization, built cities of remarkable sophistication. Mohenjo-Daro, Harappa, Dholavira, and hundreds of smaller settlements represent a civilization that, at its height, occupied an area larger than ancient Egypt and Mesopotamia combined, with standardized brick sizes, indoor plumbing connected to municipal drainage systems, and writing that has still not been fully deciphered. The civilization flourished on Indus water that began as glacial melt within 100 kilometers of the mountain, that traditions associated with its source, thousands of years before modern cartography, confirmed the connection. The Indus River currently provides water to approximately 300 million people in Pakistan and northwestern India. The Brahmaputra, Tachuk Kabab in Tibetan, the Horse River, or Yarlung Tsangpo in its Tibetan reach, originates from glaciers near the east face of Kailash, travels east along the southern edge of the Tibetan Plateau for more than 1,600 kilometers as the Yarlung Tsangpo, then makes a hairpin turn around the Namcha Barwa Peak and plunges through the Tsangpo Gorge, a canyon that reaches depths of over 5,000 meters below the surrounding plateau, making it the deepest river canyon on Earth by a substantial margin, before emerging in Arunachal Pradesh as the Brahmaputra. From there, it flows west across Assam and then south through Bangladesh, where it joins the Ganges system in the Ganges-Brahmaputra Delta before reaching the Bay of Bengal. Its combined discharge with the Ganges makes the Bengal Delta one of the highest discharge river systems on Earth. The Brahmaputra Basin supports the agricultural economy of Bangladesh and eastern India. and is the primary water source for one of the most densely populated regions on the planet. The Sutlej, Langchen Kabab, the Elephant River, rises near the west face of Kailash, flowing generally westward through the Sutlej Valley in the Indian state of Himachal Pradesh, before crossing into Punjab and eventually joining the Indus system in Pakistan. The Punjab, from the Persian for 5 rivers, was the heartland of the Vedic civilization that composed the Rig Veda and developed the cultural and religious foundations of what would eventually become Hinduism. The rivers the Vedic texts describe, the rivers their religious poetry associates with the sacred mountain at the center of the world, are the rivers whose headwaters the satellite imagery now confirms within 100 kilometers of Kailash. The Karnali, Macha Kabab, the Peacock River, originates near the south face of Kailash and flows south through Nepal, where it is joined by several tributaries including the Humla Karnali, before crossing into the Tarai lowlands and eventually joining the Ganges system as the Gagara River. The Ganges, Ganga in Sanskrit, is the most religiously significant river in Hinduism, the sacred water at the center of the faith tradition of roughly 1 billion people, bathed in as an act of purification, its water carried in vessels for use in rituals thousands of kilometers from the river itself. Traced to its furthest hydrological source, the Ganga's water begins within the drainage basin of a mountain that Hindu sacred geography identified as the throne of Shiva in the center of the universe long before any scientist confirmed the hydrological connection. The geographical fact that emerges from this survey is the same one that the ancient traditions described, and it is important to be precise about what kind of fact it is. It is not that a single stream flows directly from the summit of Kailash in 4 directions. The rivers originate from glaciers and springs distributed across the mountain's drainage basin within a radius of roughly 100 kilometers. Some sources are closer to the mountain, some further. What is unique is not that all 4 rivers spring from a single point. They do not. But that all 4 river systems are sourced within the same concentrated drainage basin, radiating in the 4 cardinal directions, with no other location on Earth where a comparable convergence of major river systems has been documented. The Himalayan Club's journal noted it directly. It is the only region where the sources of 4 major river systems are so close to each other. How did this hydrological configuration come to exist? The answer requires understanding the geological history of the Tibetan Plateau, which is itself one of the most consequential geological events in the Cenozoic era. Approximately 50 million years ago, the Indian tectonic plate, moving northward at a rate of several centimeters per year following its separation from the ancient supercontinent Gondwana, began to collide with the southern margin of the Eurasian plate. The collision zone is what is now the Himalayan arc. The Indian plate did not simply stop. It continued pushing northward, and the resulting compressive stress crumpled the Earth's crust, folded the marine sediments of the ancient Tethys Sea upward into mountain ranges, and produced the largest continental uplift in the past 100 million years. The Tibetan Plateau, which geologists understand as the crustal thickening produced by this ongoing collision, is the highest and largest plateau on Earth, averaging more than 4,500 meters. In elevation across an area roughly the size of Western Europe, the uplift of the Tibetan Plateau fundamentally reorganized the drainage of the Asian continent. Rivers that had previously flowed in different directions were captured, reversed, or redirected as the plateau rose. The rivers that now flow from the Kailash region did not flow from this location before the Himalayan uplift. The drainage configuration we see today, 4 rivers radiating from a single basin in 4 directions, is the product of approximately 50 million years of tectonic uplift that reorganized the continental hydrology of Asia around the rising plateau, with the Kailash region ending up at the center of the resulting radial drainage pattern. The shape of the mountain is a separate story with a different timescale. Mount Kailash is composed primarily of stratified sedimentary conglomerate, pebbles and sediment, cemented into rock and then uplifted by the tectonic forces of the plate collision. The Gangdais volcanic and intrusive rocks that form the broader range are interbedded with these sedimentary units, creating a heterogeneous rock mass with varying degrees of resistance to erosion. The distinctive pyramid shape did not develop during the primary tectonic uplift. It developed much later, approximately 2.5 million years ago, during the onset of the Quaternary Ice Age, when glaciers began forming on the slopes of the Tibetan Plateau and surrounding ranges. At Kailash, glaciers grew on all 4 aspects of the mountain simultaneously. Each glacier carved a cirque, a bowl-shaped hollow scoured into the mountain's flank by the combined action of glacial abrasion, frost wedging, and freeze-thaw cycling. As the 4 cirques deepened from their respective faces, the ridgelines separating them narrowed and steepened. The original rounded summit was progressively carved into the angular faceted shape visible today, a 4-sided pyramidal peak with steep faces separated by sharp ridgelines. This process, called glacial cirque formation from multiple aspects, is well understood in mountain geomorphology. It is the same process that produced the Matterhorn's iconic shape, and it has created similar pyramidal summits in mountain ranges from Patagonia to the Karakoram. What requires more careful explanation is the cardinal alignment of the four faces. The faces of Kailash align approximately with the north, south, east, and west compass. Directions, not perfectly, but with an accuracy that is visually striking when the mountain is photographed from the appropriate angles. The geological for this alignment invokes the orientation of pre-existing fracture systems in the conglomerate rock. When sedimentary rocks are uplifted and subjected to tectonic stress, they develop fractures and joints whose orientations are determined by the directions of the applied stress. Erosion, both glacial and frost weathering, preferentially follows these fracture planes, carving faces and ridges that track the fracture orientations. If the primary fracture system in the Kailash conglomerate happens to be oriented in the north-south and east-west directions, the resulting erosional faces will align with the compass directions accordingly. The tectonic stresses in the Kailash region are primarily driven by the north-south compression of the Indian-Eurasian collision, which would be consistent with producing fracture systems oriented roughly parallel and perpendicular to that compression direction, that is approximately north-south and east-west. This explanation is coherent and consistent with the established geology. It has not, however, been confirmed by comprehensive, high-resolution structural mapping of the fracture systems in the Kailash conglomerate itself, primarily because access to the mountain for scientific purposes has been severely restricted since the Chinese government established control over Tibet in 1950. This restriction is a significant scientific problem. Mount Kailash is, by any measure, one of the most geographically and hydrologically significant peaks on Earth. It is the unclimbed and largely unmeasured center of the drainage system that supplies water to more than 1 billion people. High-resolution LiDAR survey, which would precisely quantify the linearity of the ridgelines and definitively determine whether the cardinal alignment is within the expected range for rock fabric-controlled erosion or constitutes a genuine statistical outlier, has not been comprehensively applied to the mountain. Ground-penetrating radar survey, which would resolve questions about the internal structure of the peak and definitively rule out or confirm any anomalous subsurface features, has not been conducted. The hydrological budget of the twin lakes at the mountain's base, Manasaravar, one of the highest freshwater lakes in the world, and Rakshastal, a salt lake with no outlet, has not been closed with the precision that modern instruments would allow. The restriction creates the specific and somewhat ironic situation in which the most studied mountain in human cultural history, the subject of more religious attention, more pilgrimage, more sacred text, more devoted scholarly commentary across more traditions than any other peak on Earth, is also among the least measured by modern scientific instruments. The sacred texts are voluminous, the seismic survey data is sparse, the traditional knowledge is thousands of years old, the high-resolution topographic model is incomplete. What the available science confirms is the hydrological miracle. 4 rivers, 1 basin, 100 kilometers, 4 directions, 4 civilizations, more than 1 billion people. This is not disputed. It is verified by satellite imagery, by stream gauging networks, by catchment analysis, and by the long historical record of each river's importance to the populations along its banks. The geological explanation for how this configuration came to exist, tectonic uplift reorganizing continental drainage followed by glacial cirque formation producing the pyramidal shape, is coherent, consistent with established geological principles, and substantially, but not exhaustively, confirmed by the available field data. What the ancient traditions confirmed thousands of years before the science existed is a separate and genuinely puzzling matter. The Rig Veda, composed no later than approximately 3,500 years ago, describes the sacred rivers and their mountain source in terms that are geographically consistent with the actual hydrology confirmed by modern cartography. The Tibetan Buddhist texts that assign the 4 rivers to the 4 faces of the mountain, associating each with a sacred animal and a cardinal direction, are producing an accurate geographic description of a hydrological reality that no ancient measuring instrument could have established. The bone tradition's identification of Kailash as the axis mundi, the center from which the world radiates, is, in hydrological terms, a metaphor that describes something physically real, a mountain from which 4 of the continent's major rivers radiate in 4 directions, sustaining the world's civilizations along their lengths. How the ancient traditions knew what they were describing is not explained by the geological or hydrological record. Extensive ground-level observation over many generations could have established the river sources and the directional flow. The mountain's pyramid shape and its cardinal alignment would have been observable to circuit and oriented themselves relative to the compass. The integration of these observations into a cosmological framework, a sacred geography that matched the physical geography, may reflect at minimum careful empirical observation by generations of pilgrims and scholars across a span of time, long enough to produce an accurate synthetic picture of the mountain's hydrological significance. That this empirical synthesis preceded modern confirmation by millennia is, at minimum, a remarkable fact about the sustained observational tradition that surrounded this mountain. At most, it is a question that has not been answered and may not be easily answerable. How did four separate religious traditions independently identify the same mountain as sacred, associate it with the four rivers that the science now confirms originate there, and assign it the role of cosmic center in a way that matches the physical reality of its hydrological significance? The mountain is not hollow. It is not artificial. The pyramid shape has a geological explanation. The four rivers have a tectonic explanation. The cardinal alignment has a structural geology explanation. Everything that the sensationalist versions of this story claim requires supernatural or extraterrestrial intervention can be accounted for by processes that geologists and hydrologists understand in their general outlines. What they cannot fully account for is the precision of the ancient knowledge, the convergence of four traditions on the same geography, and the specific questions about the mountain's unusual surface linearity that the absence of comprehensive LiDAR data leaves open. Those open questions are where the science currently sits, not at the edge of a supernatural mystery, at the edge of an instrumentation gap, a place where the measurements that would close the question have not been made because the most scientifically important unclimbed mountain on Earth remains, for religious and political reasons, among the least scientifically instrumented. That is the real secret of Mount Kailash. Not that it is a hidden pyramid or a portal or the navel of an ancient civilization, that it is the hydrological center of Asia, the water source for 1 billion people, the subject of four religious traditions' deepest cosmological claims, the geological product of 50 million years of plate collision and 2.5 million years of glacial sculpting, and that the mountain most important to understand may be the one we have measured least. Subscribe. Because the instruments that could answer the remaining questions are getting better, and whoever gets access next will have the most important geological data set of the decade.